Bucknell University's student chapter of AIChE is proud to present The Circle of Life in Plastics. Chemical engineers rely heavily on the tool known as the material balance when analyzing many types of systems. The material balance is pretty much just like it sounds. It is used to consider the materials going into a given system and the materials going out of the same system. A general material balance around a system acknowledges what is put in and what goes out, and accounts for what is generated and consumed. If everything that goes into the system does not leave, an additional accumulation term then comes into play, and this is something engineers need to be aware of, whether it is chemical buildup in pipes or accumulation of plastic on the planet. Plastics are made using crude oil, which is cracked in a chemical process to form hydrocarbon monomers. These are simple, single molecules made of carbon and hydrogen that, when connected to other identical molecules, make a chain known as a polymer. Polymers are found in plastics, which are used in nearly everything we touch, from synthetic fibers in clothing, to water bottles we drink from, to plastics encasing our laptops and other electronic devices. When considering a material balance around a home, the plastic going in is initially made from natural gas and crude oil. After passing numerous safety tests, the plastic products are able to be touched by consumers' hands and used for whatever their functions are. And when a household is done using the plastics, the products must be discarded. This then becomes the out term in the material balance. In the past, this was the end of the story. When the product was done being used, it was thrown out. But when looking at the big picture outside of a single home and in society, the out term is not the end. In addition, more plastic is being generated in factories. The large-scale production of plastics was an engineering feat and allowed access to life-changing products for many communities. However, a problem arose because many plastics would take decades or centuries to break down, and they accumulated around landfills, highways, and other environments, a problem chemical engineers were responsible to solve. As chemical engineers, the first pillar of the code of ethics is to hold paramount the safety, health, and welfare of the public and protect the environment in performance of professional duties. Therefore, finding a solution to the accumulation of plastics on the planet is a critical, ongoing endeavor, as engineers try to reimagine the end of this circle of life of plastic waste. The mechanical recycling process has been in place since the 1980s, and is still used today for many products. Chemical engineers are continuously working on new solutions that will repurpose or break down materials that cannot go through the existing recycling procedures. This could include chemically breaking down plastics and repurposing materials, moving to cleaner products overall, and finding other innovative ways to prevent ongoing accumulation of plastics in our world. Chemical engineers must enter the profession understanding that humans exist with the planet and its other inhabitants in a delicate balance. Our choices now will impact the environment and future generations. The circle of life of plastics must be reimagined, and we are constantly working on discovering and implementing new solutions that will benefit all species of life for the future.